I'll post this. Okay, so section 9.1, we're going to start using the square root property to solve equations. Okay, we've been talking about radicals, so let's use them to solve equations. Let me just give me a second. I want to make sure that the paper is highlighted here. Okay. So, section 9.1, square root property. The square root property says this: if x squared is a number, x squared equals, say, the number k. So if that's true, then we know that x is equal to plus or minus the square root of k. And when I write this plus or minus symbol, what this means is that x equals the positive root k or x equals the negative of root k. That's what that means. It's just kind of shorthand for writing all this out, just writing a plus minus there. And you knew that already, because we know that because if we take an equation like this, x squared equals 9, we learned how to solve this as a polynomial equation. We subtract 9 from both sides, right? So if you subtract 9 from both sides, it becomes x squared minus 9 equals 0. And then what we do is we factor it. And we realize that this is a difference of squares here. So this factors as x minus 3 times x plus 3. And we know that the zero product property tells us that x minus 3 equals 0 or x plus 3 equals 0. And so we get as our solution x equals 3 or x equals negative 3. In other words, you could write it as x equals plus or minus 3. And 3 happens to be the square root of 9. And you want to really make note of this because a common mistake that people make is that they say x squared equals 9, the solution is 3. And you're actually only half right. You're missing half the solution. There's really two solutions to this equation. There's plus or minus 3. Negative 3 is also a solution. And so this makes note of that up here too. So we're going to use this property to solve equations. All right, so that was one such equation. Let's look at another one that's not too different. X squared minus 48 equals 0. So we're going to want to solve this. Okay. To use the square root property, what we're going to do, instead of doing it this way, instead of trying to factor it, we're just going to write it in the form that's up here. Okay, x squared equals some number. So what that means is that we're going to add 48 to both sides. This is contrary to what we were saying in the factoring section. In the factoring section, we were saying, get your polynomial to equal 0. Get it to look like this, and then try to factor this. But you'll see this is going to be hard to factor because this is not a perfect square. So you're going to have a hard time. So we're doing something different in this section. Sometimes both methods work. Sometimes you want to use one, sometimes you want to use the other one. This is a case where we want to use this new one, the square root property. So we're going to add 48 to both sides. So x squared equals 48. And now if we look at the square root property, it says that therefore x equals plus or minus the square root of 48. Okay, so that's pretty quick, but we can do a little bit more. We're not done yet because we can still simplify this. All right, what is this? How does square root of 48 simplify? Well, root 48, 48 has a perfect square factor. That's 16, right? 48 is 16 times 3. So what I want to do is write this as 16 times 3. And then whenever I see a perfect square factor, it comes out as the square root. So the square root of 16 is 4. And so root 48 is the same as 4 root 3. So x is really a better way to write it in the simplified form would be to write x equals plus or minus 4 root 3. And keep in mind, what we mean by that is x equals negative 4 root 3 or x equals positive 4 root 3. That's what that means. Okay? That's how we use the square root property. So on the left, we have the factoring method, and on the right, we have the square root property method. Okay. Let's look at another one. Let's look at solving. All these problems we're going to work on today are going to be involving, the instructions are going to be to solve, whether I write it or not. So 3z squared equals 108. Okay. So to use the square root property, we need the thing that's on the left to be squared. Well, it's got something squared as a part of it, but the whole thing isn't squared, right? The 3 isn't being squared. So it's not of the form that we need yet. So we need to get rid of the 3 so that it's really of this form. Okay. So how can I get rid of the 3? Well, it's right now it's being multiplied, so I'll just do the opposite. I'll divide both sides by 3. So that puts it in the form that we were talking about. What is 108 divided by 3? Let's see. 36, I believe. Yes. 108 divided by 3 is 36. Okay. So now from the square root property, we know that z is equal to plus or minus root 36. So that's what we're going to use. Z equals plus or minus the square root of 36. And then we see if we can simplify this. Well, we sure can. We know what square root of 36 is. It's 6. So z equals plus or minus 6. And again, keep in mind, this means z equals negative 6 or z equals positive 6. So when you do your homework online, you may need to enter it that way with the or. I don't know if there's a plus or minus symbol on my open math. So you may need to go and write it that other way. Okay, let's try another one. C squared plus 12 equals 0. We want to solve this. Well, it's not of the form something squared equals something else yet, because this is not squared. So let's get rid of this. To get rid of this, we'll do the opposite here. It's being added, so we'll subtract it. So we get c squared equals negative 12. Now that we know about complex numbers, that was what we talked about last time, we know that we can actually deal with this. We can write this as, let's use the square root property. It's this plus or minus the square root of negative 12. And that's not a real number. Can't take the square root of a negative number and get a real number, but you can get a complex number. And that's what we talked about last lecture. So I'm going to simplify this the same way. I can write this as 4 times 3 times negative 1. Okay? 4 times 3 times negative 1. Okay, the 4 is a perfect square, so what's going to come out? The square root of 4 is 2. All right, so this is going to be plus or minus 2. Then there's a 3. Square root of 3 is root 3. And then what's the square root of negative 1? Well, that's what we talked about last time. Square root of negative 1 is what we call I. So the answer here is C equals plus or minus 2 root 3 I. There's two solutions. Another way to write this is negative 2 root 3 I or positive 2 root 3 I. So depending on what format they want. You can either write your answer like this or write it like this. Okay? All right. So let's look at another one. Okay. We're going to deal with, we want to solve this guy. Okay? So here we want to have the left-hand side as something squared. It almost is. If the 3 wasn't there, it would be something squared. But right now, there's a 3 there. Then the 3 is not being squared. So we need to get rid of the 3. So the first step with this problem is to divide both sides by 3. Okay. And that will get the left-hand side to be something squared. The right-hand side we can simplify. Let's see, 54 divided by 3, that's 18. Okay. Now, the left-hand side is something squared. It's not x squared, but it's something squared. So what that square root property says is that whatever that something is, be it an x or anything else, that anything else will equal plus or minus the square root of whatever was on the right-hand side. So the square root property is telling us that that something else, whatever's being squared, will equal plus or minus the square root of whatever was on the right-hand side. So the x minus 3 is taking the role of x in the square root property. Okay. So we can simplify root 18. Let's do that. Let's do that up here. So square root of 18 is, we want to pull out a perfect square factor. Well, 18 is 9 times 2. So this is the square root of 9 times the square root of 2. Square root of 9 is equal to 3. So root 18 is 3 root 2. Okay. So we have x minus 3 equals plus or minus 3 root 2. What we can do now is we can add 3 to both sides because we are solving for x. Okay. So x equals 3 plus or minus 3 root 2. That is our final answer, although I want to point out we can write it another way. Remember, this means plus or minus. So there's 2 solutions. So another way to write it, or you can write it like this, x equals 3 plus 3 root 2, or x equals 3 minus 3 root 2. Those are the 2 solutions that we got. One with the plus, and then one with the minus. And both of those, if you plug them in here, will solve that equation. Okay, are there any questions so far? Feel free to unmute your mic if you want to ask verbally, but you can also chat, use the chat.
Can you do another example, please?
Yeah, we'll do another one.
Okay, thank you.
All right, so let's do one more. We're going to do 5 times a minus 5 squared plus 4 equals 104. Okay. So in the same way that we did this last problem, we want to get the thing that's on the left to be something squared. Doesn't matter what it is, just as long as the whole thing is squared. But right now I've got parts that aren't being squared. So I've got to get rid of this stuff. So my first step is to get rid of the 5 and the 4. If I divide by 5 first, I'll have to divide everything by 5, and then I'll get 4/5, I'll get fractions. I don't think I want to do that. I think the best thing to do is subtract 4 first. Okay, so subtracting 4 leaves us with this. Now I think I'm more comfortable dividing by 5. Now's the right time to do it. And so if I divide by 5, they cancel here. What's 100 divided by 5? That is 20. Okay, great. In these two steps, I've gotten it down to the form that we need. We need to have it as something squared equals something. And that's what I've got. Something squared equals something. Right? So now I can use this property. If you have that, then that something, whatever it is equal to plus or minus the square root of whatever was on the other side. So in this case, a minus 5 is going to equal plus or minus the square root of 20. A minus 5 is equal to plus or minus the square root of 20. All right, let's simplify our radical like we did before. So square root of 20. Well, does that have a perfect square factor? Sure does. It's 4 times 5. The square root of 4 is 2. So root 20 is the same thing as 2 root 5. And what do we do next? We were solving for a, so we got to get rid of the minus 5, so I'll add 5 to both sides. A equals 5 plus or minus 2 root 5. That's one way to write the answer. But if people don't like using plus or minuses, then you can do it this other way. You can write it as A equals 5 plus 2 root 5, and then write or A equals 5 minus 2 root 5. Another way to write the answer. They mean the same thing. And if you plug either one of these into the original equation, it will satisfy that equation. It will make both sides equal. The left-hand side will become 104. Okay, any questions so far? Okay, that is the square root property. Let me take a quick look in the book and see if there's a if we have any application. No word problems yet. Okay, so we'll save that for later. Okay, so let's move along to section 9.2. We're going to use this stuff in section 9.2. That's why we did it here. Section 9.2 is we're going to learn a very special technique called completing the square. And it's something that gives people, when they first see it, maybe a lot of headaches, because it's, I don't know, it's maybe different than what people have seen before. But it is a very important technique to learn in mathematics. It's used all the time. And in fact, completing the square, let me write it down here. Completing the square is how you prove the quadratic formula. So if you wanted to know where the quadratic formula came from, this is it. All right. So completing the square is a method of solving a problem by taking what's there, even if it's not a perfect square, and rewriting it so that it becomes a perfect square. Okay, so let me show you an example. We want to solve x squared minus 6x equals 7. Okay, so I'm going to do something to this to help us solve it. And it's going to seem very mysterious at first, but then I'll show you how I came up with it, okay? So what I'm going to do is I'm going to add 9 to both sides of this equation. And you're probably thinking, 9, where does 9 come from? Well, that's what I'll tell you afterwards, okay? But I want to show you what it does. So I'm going to add 9 to both sides. Okay. Well, here's what it does. The right-hand side, whatever, it becomes some number, 16 in this case. The left-hand side, though, has become a perfect square. The left-hand side has become x minus 3 squared. And you can check it. If you square this out, square out x minus 3, you can work it out on your own. Please do that. Maybe make that a homework assignment for you. I'm not going to collect it, but check it. You'll get this stuff. And that's fantastic because now we can use the square root property. Okay, so what will I do? I'll use the square root property. It says that x minus 3 is equal to plus or minus the square root of 16. So in other words, x minus 3 is equal to plus or minus 4. Okay. So if I add 3 to both sides, I get x equals 3 plus or minus 4. This is giving me 2 different solutions. When I subtract 4, I get -1. 3 minus 4 is -1. If I add 4, I get 3 plus 4 is 7. X equals 7. These are my 2 solutions. Okay. Now that, like I said, that was probably mysterious. Like where does this plus 9 come from? Well, that's the whole point of completing the square, is finding out how to come up with this number, and then realizing that if you do it right, what you'll have down next is a perfect square. Okay. So let's talk about where this number comes from. So that's the whole point of completing the square, is finding that number to add to both sides. Okay. What you have to realize here is the formula for a minus b squared. If you remember that, that was a squared minus 2ab plus b squared. Okay, that's the perfect square formula for a difference. Okay, if I put an x in here, x minus b squared, then it becomes x squared minus 2xb, but let's do it the other way around. Let me write 2bx, same thing, plus b squared. Okay. So let's look back at my problem that we had here. I had x squared minus 6x. All right, so what I'm doing is I'm matching this thing right here, I'm matching that to this right here. All right, and I'm asking, what does b have to be in order to get the 6? Well, I've got 2 times b, so therefore b must be exactly half of 6, right? It must be 3. So if I put a 3 here, then this underlined thing will be exactly the same as this underlined thing. Okay? So if I put a 3 in place of b, and then I add the 3 squared, then this thing will be that perfect square. All right? And then that's how I got from here to here, and then I knew that that was going to be a perfect square like this. I took half of this number, and then I squared it, and that's the number that went right here. Because that's what's happening here. 2 times b is this number, so that means b must be half of that number. And then the thing that's right here is b squared. And if I write that out, I can factor it as x minus b squared. So let's do another one. All right, let's do x squared minus 8x equals, oh, I don't know, it doesn't matter what I put over here, 10. Okay? and we'll solve this. So let's match this up to what we see over here. I've got x squared minus 2 times b. So what do I multiply 2 by to get 8? Well, it's a 4, right? So what comes next is a 4 squared. So what I want to add to both sides is 4 squared, so that I end up with this thing on the left. So that's what we're going to do. We're going to add 16 to both sides. The 16 is b over 2 squared. Okay, so what happens? So I get x squared minus 8x plus 16 equals, when I add those, I get 26. Oh, why did I write 24? I get 26. All right. And this is guaranteed to be a perfect square, because this formula comes from this, right? This expression comes from this expression here. So how do I get back to this? Well, whatever my b was, that's what is being, the x minus that is what's being squared. So what was my b? Well, 2 times b was 8. My b was 4. So this is x minus 4 squared. This number is always half of that number there, because that was the b, and 2 times b is this. So now I'm going to use the square root property. The square root property says x minus 4 is equal to plus or minus the square root of 26. Root 26 doesn't simplify. It factors as 2 times 13. 2 and 13 are prime numbers. They don't have any other factorizations. So there's no perfect square factors. So I just leave it like this. I add 4 to both sides. I get x equals 4 plus or minus root 26. That's my final answer. Okay. So you're going to take half of this number, square it. That's what you add to both sides of the equation. Okay. Let's do another one. I'll leave this kind of up here so you can still maybe see that. So we'll do, let's do x squared plus 14x equals 15. Okay, well here we have a plus, all right? And those problems up here we had a minus. So we better think about how we're going to deal with that. Well, the minus came from this formula, but we have a similar formula for when this is a plus, okay? What is that? Well, why did I write down there? Wasted a piece of paper. What is that? What is that? What happens there? I get a plus b squared is a squared plus 2ab plus b squared. Okay? So it's almost the same, except instead of a minus 2ab, I have a plus 2ab. But everything else is the same. It's a 2b. The 2b has to be this number. So again, b is going to be half of this. And then I'm going to add b squared. So I'm going to take half of 14, and I'm going to square it. That's what I'm going to add to both sides. So 14 over 2 squared is 7 squared. That's 49. That's what I'm adding to both sides. So I'm going to put plus 49. So I end up with x squared plus 14x plus 49 equals 15 plus 49 is 64. Okay. This is supposed to be a perfect square, because if I just run this backwards, this becomes this. A plus b squared. So it should be x plus, what was b? It was half of this, x plus 7 squared. Okay. So now I know that x plus 7 must be plus or minus the square root of 64. I know what the square root of 64 is. It's 8. x plus 7 equals plus or minus 8. Subtract 7 from both sides. X equals negative 7 plus or minus 8. I can write that another way. If I take negative 7 minus 8, I get x equals negative 15. If I take negative 7 plus 8, I get x equals 1. So these are my two solutions to that problem. So we're just adding something to both sides of the equation that make the result equal to a perfect square. And that's why it's called completing the square. You're adding that one piece that was missing that was keeping this from being a perfect square. Okay. So let's do another one. We're going to do x squared plus 4x plus 9 equals 30. There's two approaches here. I can just ignore the 9 and just look at this stuff and ask, okay, well, what do I have to add to both sides, and just add it to both sides. Or it might be cleaner if I just subtract the 9 from both sides first, so that it looks like the previous problems. Okay, so let's do that. Let's subtract 9 from both sides first. Okay. Now it looks like the other problems that we had. Now I want to know, what do I add to both sides so that I get a perfect square on the left? What do you think? Can somebody chat? You can unmute your mic and say it, or you can chat what you think that number would be. What number would I add to both sides of this?
4, I think.
Yeah, 4. You take half of this, it's 2, and you square it, it's 4. Very good. So I'm going to add 4 to both sides. What happens? I get x squared plus 4x plus 4. This is supposed to be a perfect square now. And sure enough, it's x plus 2 squared. So we took something that wasn't a perfect square, right, and we turned it into something that was. So this was just, when we got to here, it was just missing one little number that was keeping it from being a perfect square. And so we added that number. We completed what we needed to get it to be a perfect square, and that's why we call it completing the square. So now we use the square root property. All right, square root of 25 is 5. So x equals, if I subtract 2 from both sides, negative 2 plus or minus 5. Another way to write that would be negative 2 minus 5 is my first answer, negative 7. Then my other answer is negative 2 plus 5, which is 3. If you can add these together nicely so that they become numbers without radicals, you should probably just do that and write it like this. I think that's the preferred way to write it. Okay. So, okay. Let's do another one. Let's do something with, let's see what happens. In all these examples, I was easily able to cut this number in half. It was always a multiple of 2. What happens if it's not a multiple of 2? So let's try this. X squared plus 3x plus, I don't know, 1 equals 8. Okay. At this point, you can just write any number. I'm not even preparing these problems in advance. I'm just putting numbers in here, and we can always solve these.
Professor?
Yeah.
Please put the problem for me to take it out, because I can get all the parts. Please.
Oh, I'll post this. I'll post the video online. All right.
Online.
So, and I think you'll see as I move down, you'll see the other side. Okay. But yeah, I'll be posting. I've been posting links to this. So if you can look back all right? So what do we do here? Well, same thing we did here. I want to get rid of the 1, all right? Let's get rid of the 1 first. Okay, so we got x squared plus 3x equals 7. And now, what did we do before? We took half of this number and squared it. So that was 2 squared, that was 4. We added that to both sides. Well, I'm going to do the same thing. Take half of 3 and square it. Well, half of 3 is 3 halves. 3 halves squared is 9/4. So that's what I'm going to add to both sides. Okay, so let's do that. So I'm going to take x squared plus 3x. I'm going to add 9/4 to the left, and I'm going to add 9/4 to the right. This is supposed to be a perfect square now. All right, it should be. Let's see if we can see what it is. Well, you know, we kind of know how it's supposed to work out, because when we, where was the, oh, here's the formula down here. The thing that goes right here that you add when you square is exactly, I mean, 2 times that is what appeared next to the x. So 2 times that is right here. So that thing must be 3 halves. So I know that my perfect square must be x plus 3 halves squared. Whatever this thing was, when you divide that by 2, that's what goes in here. And you can check it. If you square this thing out, you work it all out, you'll get this. Okay, let's simplify the right-hand side. 7 is the same as 28/4, right? So 28/4 plus 9/4 is 37/4, all right? So we know that x plus 3 halves is equal to plus or minus the square root of 37/4. And that's equal to plus or minus the square root of 37 divided by the square root of 4. But the square root of 4 is just 2. Right? So if I subtract 3 halves from both sides, I get this. Negative 3 halves plus or minus the square root of 37/2. Okay? Any questions here?
How did you get the 28 again?
Oh, I viewed 7 as a fraction, 7/1, and then I multiplied the numerator and denominator by 4.
Okay.
You get 28/4. So I'm just getting a common denominator so that I can add these. 28 divided by 4 is equal to 7. We have a question here. Where did the -2 come from? When was that asked? It was just, okay, just now. Oh, that was maybe the other one over here. Where did the -2 come from? Were you asking about this question? I'm not hearing back. If you were, I subtracted 2 from both sides here because I wanted to get x equals. Okay. Let's see. Let's try another one. Okay. We'll do, let me think, x squared plus 2x plus 4 equals 0. Okay, let's see what happens here. I'm going to solve this. So the first thing I'm going to do is get rid of that plus 4. Okay, because I want this to just be that piece that we were working with before. So we subtract 4 from both sides. So I just get this. Now I want to complete the square. I want to add something so that what I have is of this form, right? So that something is always going to be half of this squared. So what would that be? Well, half of 2 is 1. 1 squared is 1. So I'm going to add 1 to both sides. That's the completing the square step. So x squared plus 2x plus 1. Negative 4 plus 1 is negative 3. Okay. Now, this is supposed to be a perfect square. And we know that it always becomes x plus just half of this. So x plus 1 squared. And you can check it. If you multiply it out, you'll see you get exactly this. Okay. So now we use the square root property. So x plus 1 must equal plus or minus the square root of negative 3. And because we've talked about complex numbers, we know how to write this down, right? Plus or minus, root negative 3 is the same thing as root 3 times I. Right? When you take the square root of a negative number, it's the same thing as positive thing times I. And it's plus or minus, right? So what I'm going to do is I'm going to subtract 1 from both sides. Well, I have 3 things over here, so I subtract 1 from all of them. So x equals negative 1 plus or minus root 3 I. That's what we write our final answer as. There's 2 answers, negative 1 minus root 3I and negative 1 plus root 3I. So complex numbers can happen as well. And you will always get an answer here. If you're willing to use complex numbers, then no matter what coefficients you put here, you'll always be able to get a solution. Okay. Let's try one where we have a coefficient in front of the x squared. Here we want to solve this equation. Well, what we were doing depended on the fact that the coefficient in front of x squared was a 1. All right? If it's not a 1, then there's no guarantee that just adding half of this squared is going to work. Okay? So what we want to do is we want to turn this into a 1. We want to get the coefficient in front of x to be a 1. So what we'll do to get that to happen is we'll divide through by that coefficient. All right, so I'm going to divide both sides by 3. So the idea here is that we want the coefficient in front of x, in front of x squared, sorry, to be 1. All right, it's very important. Otherwise, the technique as I showed it to you, there's a way to do it when it's not 1, but it's more complicated. And I think it's the easiest thing to do is just make it 1. The technique that we learned requires the coefficient here to be a 1. So that's why I'm going to divide both sides by 3. So 3x squared divided by 3 is x squared. There, it's a 1. Good. 12x divided by 3 is 4x. 15 divided by 3 is 5. 0 divided by 3 is 0. There, it's a 1. We were very fortunate in this case that no fractions appeared. But if fractions did appear, it's no big deal. You can still solve it. You follow the same techniques. Everything will work out fine. It's just, it'll be a little messier. Okay, so what do we do next? We add 5 to both sides. That's just to get rid of this negative 5, right? So now we just have x squared. Oh, no, it's not a 0 anymore. I added 5 to it. X squared minus 4x equals 5. Now I want to add something to both sides. Well, what is that something going to be? Well, I always take half of this number and square it. So half of 4 is 2. 2 squared is 4. So I'm going to add 4 to both sides. So we get x squared minus 4x plus 4 equals 9. And the reason I did that, that's completing the square. This has become a perfect square. Now notice the minus sign here. That means it's going to be of the form x minus half of this squared. If that's a minus, this is a minus. Okay. If you pick the right number here, this thing will always be a perfect square. So now we come up here. We use the square root property. X minus 2 must be, oh my goodness, must be equal to plus or minus the square root of 9. That's what the square root property says. That means that x minus 2 is equal to plus or minus 3. Add 2 to both sides. X equals 2 plus or minus 3. When they're both real numbers, or if one doesn't have a radical or something, you may as well just combine them. I think it's just easy. It's nicer to write it like that. So let's write this like this. 2 minus 3 is negative 1. And 2 plus 3 is 5.
Can I ask a question?
You sure can.
Yeah, I can also do here by factoring, right? X squared minus 4x minus 5.
Yeah. This one was actually factorable. Yeah. So yeah, that's a good observation. Yeah. When you get whole numbers here, it turns out we could have solved it just by factoring.
Yeah, thank you.
But we are getting, yeah, it's a really good question. But we are getting answers that we weren't getting by factoring, like this one up here. All right, so the method is still important. You can't just say, well, I'll just use factoring and everything, because it's not going to get you answers like this. Okay, so
when it is possible, right?
sorry?
When it is go by the factoring, then we can.
Yeah, if it's factorable, you can go ahead and factor it like that.
Okay.
Yeah.
Thank you.
I'm trying to pick examples that work out nice so as to not, throw a whole bunch of details in your faces, right? So I'm picking problems that are so nice that maybe other methods work as well. Right?
Thank you.
Sure. Let's look at another one. I think we'll do a couple more and then maybe that'll be it. So 4x squared plus 3x equals 2. Okay. All right. Well, like I said, we want the coefficient in front of x squared to be a 1. All right. So we got to get rid of this 4. So what do? We divide by it. Divide everything, both sides of the equation, by 4. Okay, so I'm going to have 4x squared divided by 4. That gives me the x squared. But then I have 3x divided by 4. That's 3/4 x. No way to avoid that fraction, unfortunately. 2/4 simplifies to 1/2. Okay. So we've created fractions in our problem, but we do have a 1 in front of our x squared. So that's what we wanted. Okay, so now we're going to complete the square. Okay, we're going to try to find the number that we would add to both sides so that this will become a perfect square. And we know how to get that number. We take half of this and we square it, right? Well, what's half of 3/4? Well, that's 1/2 times 3/4. That's 3/8. And I want to square it. So what's 3/8 squared? That's 9/64. Just square the numerator and the denominator. That's what I have to add to both sides. 9/64. Okay. So the left-hand side becomes x squared plus 3/4 x plus 9/64. The right-hand side, well, I've got to add 1/2 and 9/64. Okay, let's do that over here too. So 1/2 plus 9/64. I need a common denominator. Well, I can get this to be denominator 64 if I multiply the numerator denominator by 32. Okay, so 1/2 becomes 32/64. Now that the denominators are the same, I can add them. 32 plus 9 is 41. Okay, so that's what the right-hand side is. And we've completed the square, so we can write this as a perfect square. And remember, the thing that I put in here is always half of this, so it's going to be 3/8. That's what half of 3/4 was. But you should always check this. You know, make sure you go through and just check, square it out, make sure you do actually get this. All right? At least think it through in your head. You may not need to work it out on a piece of paper, but at least make sure that that was correct, because it's easy to make the mistake in here and add the wrong thing. Don't assume that everything worked out just fine. Don't assume you didn't make a mistake somewhere. So I do that all the time. Whenever I write that thing down, I look at it and go, wait, does this really work? If I multiply this out, does it really give me this? Very important to check. It seems like that's the most likely place to make a mistake. It's right in here. Okay, so I got something squared equals something. So x plus 3/8, that something must be plus or minus the square root of what's on the right-hand side. Okay, well, this is the square root of 41 divided by the square root of 64. Nothing I can do about 41. Square root of 41 is just square root of 41, but square root of 64 is 8, right? So that's nice. Now I can subtract 3/8 from both sides. Oh, didn't mean to write that there. All right, so x equals now negative 3/8 plus or minus root 41/8. Now they have a common denominator, so I could also write it x equals negative 3 plus or minus root 41/8. Another way to write it. There's alternative ways to write down the same thing. Okay, so you could write it like this, or you could write it like this. Or you could write down the two solutions separately, one with the plus and one with the minus, with an or in between. Okay. Any questions there?
Professor, why you put a negative 3/8 and then you put back the negative 3/8?
Well, I had plus 3/8, so I subtracted it from both sides.
Oh.
So I wanted to get x by itself.
Mm-hmm.
So I want to get rid of the plus 3/8. So to get rid of plus 3/8, I subtract 3/8. And then
you could put an equal sign in between, right?
Yeah, this was a mistake. I didn't mean to write anything there at all.
Mm-hmm.
I just goofed and wrote an equal sign. But there should be nothing there. Any other questions? Okay, I just want to do one more thing. We are going to prove the quadratic formula, all right? So what is the quadratic formula? The quadratic formula says that if you have a polynomial like this, ax squared plus bx plus c equals 0, it tells us what the solutions are. It gives you a very quick formula. It's a formula for the solutions. How do you get that formula? Okay. Well, the first thing you do is you want to get a 1 in front of the x squared, right? Just like we did with our last two problems. We wanted to make sure the coefficient in front of the x squared was a 1. So you divide everything through by a. Okay. What happens? Well, ax squared divided by a, the a's cancel. You just get x squared. Bx divided by a, well, that's b over ax. C divided by a, c divided by a. 0 divided by a is 0. 0 divided by any non-zero number is 0. We're assuming a is non-zero. Otherwise, this wouldn't be a quadratic. We wouldn't even need a formula to solve it, right? So assume a is non-zero. All right. Now, we want to get this stuff alone, so we subtract the c over a from both sides. Okay. So we get x squared plus b over ax equals negative c over a. I just subtracted it from both sides, so it canceled out over here and reappeared on the right-hand side as a negative. Now, I want to complete the square. So I want to add something to both sides so that the left-hand side becomes a perfect square. And we know what we're supposed to add. We're supposed to add half of whatever this is. So let's just figure that out over here. What's half of b over a? Well, just multiply. It's b over 2a. And I'm supposed to square that. b over 2a squared is b squared over, well, 2a squared is 4a squared. So that's what I need to add to both sides to get this to be a perfect square. Okay, so we do it. We get x squared plus b over ax plus b squared over 4a squared equals b squared over 4a squared minus c over a. Okay, a little messy, but if we just kind of keep track of what we're doing, we can be sure we're doing it right. All right, just added these, got this, just added this to this stuff, got this. Now, it's guaranteed that this is a perfect square. That's always x plus something squared. What goes in here? Well, what goes in here is always half of whatever the coefficient in front of the x was. What was half of b over a? Well, we computed it right here. It's b over 2a. So that's exactly what goes here. If you square this out, you will get this stuff. All right. What happens on the right-hand side? Well, we want to combine these two fractions. To combine them, we need a common denominator. So right now, we don't have a common denominator. Let's do that over here. I want b squared minus 4a squared minus c over a. Well, I need to get a 4a squared in the denominator. So what I'll do is I'll multiply the numerator and denominator by 4a. So I'm leaving the left fraction the same, b squared over 4a squared. I'm multiplying this one by 4a. So I get 4ac, and in the bottom I get 4a squared. That's just c over a is the same as this. These are the same. Just multiply the numerator and denominator by 4a. Now they have a common denominator, so I can combine them. I combine their numerators, b squared minus 4ac. This is what that fraction becomes. It's very symbolic because we're just using letters here, but that's what it is. b squared minus 4ac over 4a squared. That's what you get when you combine these. Okay. So now we use the square root property. It says that x plus b over 2a, the thing that was squared, is equal to plus or minus the square root of this stuff. But when you take the square root of a fraction, you can take the square root of the numerator and denominator separately. So that's equal to plus or minus the square root of b squared minus 4ac divided by the square root of the bottom. What's the square root of the bottom? Well, the square root of 4 is 2. The square root of a squared is a. And all that's left now is to subtract b over 2a from both sides. So if I subtract b over 2a from both sides, we get x equals negative b over 2a plus or minus that stuff. And usually when they write down this formula, they write down it with as a single fraction with a common denominator. So let me try to squeeze that down in here. They're gonna write negative b plus or minus square root of b squared minus 4ac over 2a. That is a very special formula called the quadratic formula. And you can use this formula to solve any second degree polynomial equation. So if we went back, I know that was a lot of symbology going on there, so you probably want to look at the video later, rewind and look at that more, in slow motion or something. But if you had a problem like this, well, look at this. I got ax squared plus bx, okay, the b is negative, but it still works, plus c equals 0. So a is 3, b is negative 12, and c is negative 15. If I just plug those numbers in for a, b, and c into here, I'll get the same answer that we got over here. That formula will spit out the exact same thing. So it will solve any second degree polynomial equation that's set equal to 0. And you can always arrange that it is. So that's completing the square is where the quadratic formula comes from. So that's a very important application of it. Okay. I don't expect you to go through this proof on your own. Don't worry about that. I'm not going to have you do that. But I think it's very important that we see where that formula comes from once we have the tools to do it. All right. So that's all I have for today. Like I said, I'll share this video online. And I've shared the previous videos that we've done online. It takes me a little while to process the videos, so I can't just upload it right after class. It's kind of they're big files, and it takes a long time for my computer to process it. So give me a couple days, but I'll post these things as I can. Any questions?
Yeah, should we use the formula, or we should solve the problem?
If it asks you to complete the square, then I will need to see the work of completing the square. All right. If all it says is solve, yeah, you can go ahead and use the quadratic formula. But you better believe that on the exam, I'll ask you to complete the square. So you'll need to know how to do that. Okay, you can't
we can use it for check also, right?
Yeah, absolutely. You can use it to check your answers. Yeah. Other questions?
I don't know where to find the recording, but I searched, I didn't get it.
Oh, it's I'll show you right now.
Okay.
So I'll share my browser screen. Okay, so you should be seeing the browser. You just go to our our home page here. I moved it. I had the videos down below near the assignments. I posted them right here now. At the very top of the page in the Zoom class meetings section, I have recorded lectures. So as I record lectures, I will post them here. If I make other videos though, that are specific to the particular topics that we're covering, which I may not do as much anymore since I'm doing all the lectures now, I will post those down below near the assignment. And so I did do that a few times. Some of these videos down here in the chapter 8 section, some of these are ones I made, maybe, I don't know, I don't remember which ones. I know these are. So I did post some videos down here as well, okay? But the recorded lectures that we're doing now, I'm gonna post those right at the top of the page, okay?
It was not shown on my page. I will check today.
You should check. It says showing always, so that tells me that it should be showing to the students. Let me put my student view on. This is something I just made this. This was previously in the announcements section, and I just put these things here just like 1 or 2 days ago. So it's a recent thing that I've been posting.
Okay.
Okay. I think I had them linked down below before, but now I'm putting them right up top. But like I said, there still may be other important videos that you should check out down near the homework problems, okay? So don't just look up there. Any other questions? Doesn't look like it. Okay, so I'm gonna look at, after my computer finishes processing this video, which takes like an hour, I'm gonna look at that problem number 10 and I'll see if I can resolve the issue that it's having, okay? And I'll send an email out when I check that out. When are we having another class on Zoom? That's a good, yeah, there may be another, it may be 9, 10, 11, and 12. I'll check the whole set of 4 questions there. When are we having another class on Zoom? We're gonna do this, I'm gonna do it every Tuesday, Thursday. And it's gonna be the same link, same password, same meeting number if you had to use that to get in. I plan to use those same things. Unless I'm forced to change them, I'm not gonna change those. So it should be the same way you got to this meeting every Tuesday, Thursday at the same time.
But you're changing the ID.
I don't think I'll change the ID. I believe I found a way where I don't have to do that.
Because I used the one from last week and it showed invalid. So
Yeah,
to go into my,
the one from last week may not have worked.
yeah.
But I think the one we used today and on Tuesday, that should be the same link from now on.
Okay, all right. Thank you.
I learned how to do that in Zoom. I didn't know how to do that before.
The officer is same time I will get you. Office hour, your officer?
So I'm not holding usual office hours, but if you want to schedule a time to meet with me face-to-face, totally do that. The reason I can't do the usual office hours is because after they come right after my class, my Calculus 3 class. And like I said, as soon as I finish class, it takes my computer like 45 minutes to process the video. And I can't run another Zoom video while it's processing the previous one. So I just can't really do it.
Okay, then if any problem in homework, then I will just text on the forum.
Yeah, just email me.
Okay.
Message in the forum if you want. If you want to meet with me face to face, I can totally do that. I'll be happy to meet with you.
Yeah.
I just can't do it at the office hours that I had scheduled there. Right? So if anybody, that goes for everybody. If anybody wants to meet face to face and talk about problems, I can take some time out to do that. Just let me know.
Sure, thank you.
Sure. Any other questions? Okay, that looks like it. Okay, so I'll look into those problems that were giving people difficulty, and I'll be posting some homeworks, not due this Sunday, but due the following Sunday about the newer material as well. All right, so have a good weekend, everybody. I'll see you next Tuesday.
Thank
Bye.
you.
Thank you.